Hello everyone. In this problem, there is a reaction between A and B to form C and D. They are all in the gaseous state, and the chemical formula is given. And two experiments were performed with different amount of A and B. And after the reaction, the leftover is different in two experiments. So if A is left over in the first experiment, B is left over in the second experiment, for example. And the amount of gas D after the second experiment is 45/8 grams. And there is a ratio between all the gases over C after reaction. After the first experiment, the ratio is 3, and after the second experiment, we don't know the ratio, the value of X. So we want to find the value of X times the molecular weight of C over molecular weight of B. So if we compare the amount of A and B in the two experiments, in the second experiment, both the A and B amounts increased, but the percentage of increase is much higher in B than in A. That means in the second experiment, B will be left over. That means A will be left over in the first experiment. So let's make a table for the amount of each substance before and after the experiment. So there are 4 reagents: A, B, C, and D. So before the first experiment, the amount of gas A in mole is 4 times V divided by the molar volume of A. Let's say the molar volume of A is VA. And the amount of gas B in mole is 6 grams divided by molecular weight of B. And after the experiment, the leftover is A So 17W is divided by molecular weight of A. And B is all consumed in the first experiment. That means the amount of C and D produced will be the 2/3 of the amount of B according to the ratio in the coefficient of the chemical formula. So if 6/MB mole is consumed in B, 2/3, that means 4/MB mole of both the C and D will be produced. And then the ratio of the total gas over the amount of C is 3, because the same amount of C and D are produced after the reaction. To have the ratio of 3, the amount of leftover in A should be the same as the amount of C or D that is produced. So from the ratio of 3, 17W over MA is equal to 4/MB. And the amount of A participating in the reaction from the first experiment is the difference in the amount before and after the experiment. And so subtract the leftover from the initial amount, and then the amount of B. This ratio is 2:3 from the chemical formula. So if we solve this proportion, a 12/MB is equal to 3 times 4V/VA minus 17W/MA. And then because 4/MA is equal to 17W/MA, this means 4V/VA is equal to 34W/MA. And because this is the number of mole in gas A before the experiment, the volume, the mass of A in volume 4V is equal to 34 times W. So in the second experiment, I'm going to change the volume to mass in gas A because 4V is equal to 34 times W. 5V is equal to 42.5 times W. So for the second experiment, (42.5 W over MA) number of mole was present in A, and for B, 25 is divided by a molecular weight of B. And after the second experiment, B is left over, so 40W over MB remains. And in the second experiment, the same amount of C and D will be produced as the amount of A consumed. So 42.5 W over MA, both the C and D, this amount of mole, 42.5 W over MA, will be produced. And the ratio participating in the reaction between A and B in the second experiment is this two, the difference between 25 over MB and 40W over MB. That's 2 to 3. So if we solve this proportion,
이거 안 막이 돼? 갑자기 돼? 20초 세라 20초 술래잡기 형 20초 세 어? 정말요 형 20초 세고 냈다가
so we get this equation. So if we compare these two equations, MB over MA so the ratio of the molecular weight of A and B is 4 over 17W from the first proportion, 50 minus 80W over 127.5W from the second proportion. So if we make the cross product, (510W) is equal to the 17. So we can cancel W in the denominator. So 510 equal to 17 times 50 minus 80W. So if we divide both sides by 17, actually 170, 3 is equal to 5 minus 8 times W. So that means W is 1/4. And if W is 1/4, the ratio between the molecular weight of B and A is 16 over 17. So let's say the molecular weight of B is 16K, and the molecular weight of gas A is 17K. And then we want to find the ratio of the all the gases over gas C after the second experiment. So value of X is the sum of these three. That's the numerator. So 40 over MB plus 85 over MA. And the amount of C is 42.5 over MA. I just omit the W's. And then if we use 16K for ND, and 17 for MA, the value of X is 3. And then the amount of gas D after produced in the second experiment is 45 over 8. So that means this is equal to 45 over 8 divided by molecular weight of D. So if we solve this equation, the W is 1/4, so 42.5 over 4 times MN is equal to 45 over 8 times molecular weight of D. That's D. So cancel these two. So that means 85 times MD is equal to 45 times MA. So 17 MD is equal to 9 times MA. And because MA is 17K, this means molecular weight of D is 9 times K. And to find the molecular weight of C, we can use the chemical formula because mass is conserved before and after the reaction. The mass before the reaction is 2 times a molecular weight of A, which is 17K, and for B, 3 times 16K. That's equal to the mass after the reaction. So 2 times molecular weight of C and 2 times molecular weight of D is 9K. So if we cancel 2 in each term, 17K plus 24K is equal to MC plus 9K. So the molecular weight of C is 32 times K. So finally, the value we want, X times MC over NB, is 3 times the value of X is 3. MC is 32K over NB is 16K. So 3 times 2 is 6. So the answer is 6 in the fourth choice. That's for this video, and thanks for watching.